All right, so last lesson we discussed in general sequences as well as series, so we became comfortable with what a sequence is, as well as how to write rules for sequences, write summation notation for series, and how to work with all of those, manipulate them. Now, in this lesson, we're going to focus on a very specific type of sequence and series, and those are what are called arithmetic. So we're going to talk about arithmetic sequences and series. So in order to talk about them, we should probably know what they are. An arithmetic sequence is a specific type of sequence where the difference between consecutive terms is constant. And if you don't know what constant means, it means stays the same. So meaning whatever the difference between the first two terms is, the next two terms should have the same difference. So constant difference, we call that the common difference. So if I have a rule where, A1 plus, or A1 comma, not plus, that would be a series, A2, A3, dot, 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 then A2 minus A1, that would give you the common difference. A3 minus A2 should also give you the common difference. So again, it's the next term minus the one before it. That is how you come up with the common difference. So on this one, we always do I'm trying to think of how to word it. So I don't want to say second minus first, but later minus earlier, I guess we could say, because it's not always the first and second. You might choose the third and the second, but whatever the later term is in the sequence, you subtract the earlier term, the one right before it, to find that common difference. An arithmetic series is just an expression formed by adding the terms of an arithmetic sequence. So you can see I almost put the pluses in there. That would have been a series. So we do have rules that specify for arithmetic sequences, which in 11.1, that seems to be an area where a lot of people struggle, is that because when you are trying to write the rule or write the formula, that you can't just do the same thing every time and think you're going to get the answer. It's all about looking at it, observing the patterns, and trying to come up with something that would describe it. Arithmetic sequence, we have an actual formula for the rule. It's always going to be, so A sub n, that's the rule, A sub 1, which is standing for your first term, plus n minus 1, so n is the term number, times d, where d is the common difference. So they're all going to fall into the exact same format. So those of you who don't like logic puzzles, which is kind of like what 11.1 is, might be more comfortable in 11.2. So A sub 1 is the first term, d is the common difference. Then we also have a rule that describes the sum of the first n terms, and this is for a series. Again, sum means it's a summation, but the rule would be that it's going to be n, whatever the term number is, so the upper limit, times first term plus last term divided by 2. So that's going to be your sum. And notice that this is only for finite arithmetic series. You can't do that for an infinite series because we can't plug in infinity. All right, so let's look at some examples. Example 1, decide whether the sequence is arithmetic, explain. So definition says the difference between consecutive terms has to be constant. So we need to find that difference and see if it's constant. So 11 minus 17 is negative 6. So try the next pair. 5 minus 11, also negative 6. So try again. Negative 1 minus 5. Okay, so far so good. Negative 7 minus negative 1. This becomes a plus plus. So yes, this is arithmetic because it has a common difference of 6. So we just showed that they all had a common difference, but our explanation just tells us that there is the common difference. All right, next one, I do the same thing. So I do negative 6 minus negative 10, which, again, these turn into pluses. That would give me 4. So then the one after that, negative 2 minus negative 6, plus plus, that's 4. Then, let's see, I started with negative 2 here, so now I'll start with 0. 0 minus negative 2, plus plus, equals 2. So right here on the third term, I got a difference that was different, which means it's not common. So this is a no, because the difference isn't constant. It stayed the same twice, but not for all. And constant means every single time. So that's a no. Example 2, write a rule for the nth term of the sequence, 32, 47, so on and so forth. Then find a sub 12, so the 12th term. So again, like I said, this is not as much of a puzzle as what we had in 11.1 is, because here I have a formula. So if I want to write a rule here, I can say a sub n equals, and then a sub 1 is the first term, so that would be 32. I'll just write out to the side anything that I plugged in. So a sub 1 was 32. Then the next part, plus n is what we don't know because we're saying for the nth term, so n stays n here, n minus 1 times d is the common difference, so I probably should find that. 47 minus 32 is 15. So my common difference is 15, so that is what should go here. So now I just need to simplify. Don't leave it like this. That's not simplest form. So 15 times n is 15n. 15 times negative 1 is negative 15. So combine my like terms, the 32 and the 15. My a sub n, my rule, should be 15n plus 17. Then it says find a sub 12. So I'll do some work over here. A sub 12, I should just be able to plug in 12. So 15 times 12 plus 17 should give me my answer. So that's 17. This is 180. So that means a sub 12 should be 197. So again, follows into a very direct pattern every time. Example 3, write a rule for the nth term of the arithmetic sequence. All right, so similar, except instead of them giving me the sequence, they gave me some information. They gave me the common difference, and they told me the 20th term. So this is way different than what I was given in example 2. If I know the 20th term, this means when n equals 20, a sub n is negative 111. So that is helpful because I can plug that in. I can plug two things in. I can plug in an a sub n value, and I can plug in an n value. I also have d. So I'm going to plug in all three of those things. So I've got d, I've got a sub n, and I've got n. I'm going to plug all three of those things into this formula. So same formula, we're just given different pieces. So for a sub n, I'm going to plug in negative 111 equals. A sub 1 is what I don't know here. I need to find that out so that I can write my rule. So a sub 1 plus, I know n this time, so 20 minus 1, because n minus 1, times d, it says d is negative 6. So negative 111 equals a sub 1 plus 19 times negative 6, which is negative 114. So to get a sub 1 by itself, we add to both sides here. So that means a sub 1 had to be 3. So the first term of my sequence was 3. Now I can take that and plug it in and get the general rule for the nth term. So a sub n is going to equal first term plus n minus 1, because I'm back to the general nth term, times negative 6. So distribute here, 3 minus 6n plus 6. So a sub n equals negative 6n plus 9, or if you put 9 minus 6n, that is perfectly fine as well. So there is my rule. B, similar idea, but again, I'm given different pieces. I'm told a sub 5 is 10. So that means when n is 5, a sub n is 10. Okay, this information, it's the same thing except different numbers. So when n is 30, a sub n is 110. So I'm going to plug that in. This first one, a sub n is 10 equals a sub 1, which I don't know, plus n minus 1, which would be 5 minus 1, times d, which I also don't know. So I'll simplify that. So that's going to give me, when I move it over here, 10 equals a sub 1 plus 4d. Can't solve that. It's got two variables. So let's look at the other thing that I'm given. So 110 equals a sub 1 plus 30 minus 1 times d. So if I simplify that, 110 equals a sub 1 plus 29d. Now, this should look familiar, and we just reviewed it on our Flashback Fun Day. Here, this is a system of equations. I have two variables. A sub 1 is a variable, d is a variable. These are nicely lined up for an elimination. The only thing you need to do is multiply the second equation by negative 1. So negative, 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 and I'm going to be able to solve. So 10 plus negative 110 is negative 100. A sub 1 plus negative a sub 1 is 0. Those cancel out. 4d plus negative 29d is negative 25d. So you can see here, now I can very easily find my d. D is 4. And if my whole goal is to be able to write an a sub n, I need to be able to find a sub 1. So once I know this, once I know what d is, plug it back into one of these. I would certainly pick the one that's easier. So take d equals 4 and plug it in to this guy right here. So 10 equals a sub 1 plus 4 times 4. So 10 equals a sub 1 plus 16, which means a sub 1 is negative 6. So now, if I look at this, this now is what I have here. A sub 1, I have d, so now I can write my final answer, which is that a sub n is going to equal negative 6, because that's my a sub 1, plus n minus 1 times d, which d is 4. So distribute, and this would be 4n minus 4. So that gives you 4n, negative 6 plus negative 4 is negative 10. Now, That took a while, but notice the reason why I try to review all the things that you should know is because you never know when they're going to pop up. And here's a system of equations popping up in sequences and series. It's multi-step, but all of it is little steps that you should be able to do. So don't be surprised when those pop up for you. All right, example 4, given the series, so now we're looking at series and not sequences, find the sum of the first n terms, and then find n for the given sum, meaning if you know what the sum is, can you figure out what term number it was? So here's my series, 20 plus 18 plus 16 plus 14. So sum of the series formula is right up here. S sub n equals n times a sub 1 plus a sub n over 2. Now, this wants to know, I want to find the sum of the first 25 terms. So the first thing I need to do is figure out what the 25th term is, because you cannot find the sum without finding the last term. So I need to find a sub 25. So I can do that the exact same way I just did above. I can use this formula, a sub 25 equals, so a sub 1 is 20, plus n minus 1, so 25 minus 1 is 24, times d, 18 minus 20 is negative 2, so that's my common difference. So 20 plus negative 48 is going to give me negative 28. So my 25th term would be negative 28. That's important because I can't solve the sum till I know the first and the last term. So s sub 25, which is what I'm looking for, equals n, which is 25, times first term, which is 20, plus last term, which is negative 28, divided by 2. So 20 plus negative 28 is negative 8, divided by 2 is negative 4, so that gives me 25 times negative 4, which gives me a final answer of negative 100 for part A. So the sum of the first 25 terms would be negative 100. Now, even though it seems like, oh, so much work to do all this formula, can you imagine how much more work it would be to write out 24 terms of the series and then add them all together? This takes up a lot less room than that. All right, B. B tells us what the sum is, and we want to find n. So that means I want to know what term number it is. So if I look at this, I know that Sn equals negative 760. So negative 760 equals n, which is what I want to know, times a sub 1 plus a sub n over 2. Now, notice I've got a lot of variables and some that I don't know exactly which ones they are. I plugged in for negative 760. I can plug a sub 1 in, that's 20. But I need to know what a sub n is. So I need to find that first. So a sub n, again, going back to this formula here, equals a sub 1, so 20, plus n minus 1 times d, which we know is negative 2. We found that for the last part of the problem. So distribute 20. This would be negative 2n plus 2. So these are like terms. So a sub n is going to equal negative 2n plus 22. So that's helpful because we can put that in now. So take this and put it in here. So negative 760 equals n times 20 plus negative 2n plus 22 over 2. So order of operations I need to follow. On the right side, in the top, 20 plus 22 is 42. And then I've got negative 2n, so that's negative 2n plus 42 over 2. Now, I can do a couple different things here. I notice that all three of these terms happen to be divisible by 2. So I can actually divide this first thing by that 2 and simplify. If you don't notice that, you can still solve this equation without doing that, but it just makes your numbers smaller if you reduce your fractions. So that's going to give you negative n plus 21. So now distribute negative 760 equals negative n squared plus 21n. So this is quadratic. Again, look at all of these things that pop up, stuff that you've got to know, solving systems, solving quadratics. If I want to solve the quadratic, I need to move these two over to the left side. So n squared, when I add it, minus 21n, because this one would need subtracted to the other side, minus 760 equals 0. Now, if this doesn't factor, you would have to do the quadratic formula. Because there's no number here in front of the n squared, which if you forgot to reduce here, there would be a 2, but you could take it out with GCF. So again, it's no problem if you forget to reduce here. You'll just have to take the GCF out when you factor. So now you're probably going to need some help with the calculator because we're looking for factors that multiply to negative 760 and add to negative 21. And I don't know about you, but I don't know any factors of negative 760 other than negative 76 and 10 off the top of my head. So you're probably going to have to play around a bit. And in fact, I would like for you to pause it and actually find how to factor this and then come back to see if you got it right. So you're trying to find things that multiply to negative 760 and add to negative 21. All right, so hopefully the factors that you came up with are positive 40 and negative 40, positive 19, that gives you negative 21. So that means you put these two things right in your parentheses, n minus 40, n plus 19 equals 0, which means n is 40, or n is negative 19. Now, this was quadratic, but this doesn't make sense to have two solutions because it says find n, meaning find the term number that has this sum. You can't have a negative term number. You have the first term, the second term, the third term, so on and so forth. You cannot have a negative term number. So this doesn't make any sense for the situation we're dealing with, which means that our answer is n equals 40. All right, almost done. Last one, example 5. Find the sum of the series. So it has a summation symbol. So this is just testing, do you know how to use the summation symbol to apply it to this same rule? So S sub n, so we're trying to find S sub 45 because it always goes from I equals 1 to n. So we're trying to find S sub 45, which means that we need n, so that's 45. That's the first part of the formula right up here. Then the first term, so the first term would be at the initial number. So a sub 1 is going to be when you plug in 1. So 11 plus 4 times 1, which is going to give you 15. So a sub 1 is 15, so I can plug that in, plus a sub n. So I need a sub 45. So 11 plus 4 times 45, which 4 times 45 is 180, plus 11 is 191. So plus 191 divided by 2. And now we just need to plug this in. So 15 plus 191 divided by 2, then multiplied times 45 should give you a sum for your series of 4,635. All right, so double check your work, try, hopefully, I know I can color code and you can't, try to keep it organized, to separate, so when you're looking back at your notes, you can figure it out. But I think that is it. Math. Ba-da-da-da-da. I'm loving it.